All right. Hello, everybody. Welcome to 5.1 Introduction to Data Collection. So we're going to start by reviewing the 4 steps to the statistical problem solving process. So those 4 steps, if you forgot, number 1 is to ask questions. Let's put that on there. All right. Ooh. Ask questions. Step 2 is going to be collect data. And we went over this a couple times back in the first semester. So hopefully this sounds familiar. Step 3 is analyze data. And step 4 is to interpret results. Now, that first step about asking questions, when you ask a question, it has to be a valid statistical question. So what makes a valid statistical question? A valid statistical question is based on data that vary. Let me see if I can adjust this real quick. Try to make this a little bit easier for me to write on. All right. All right. Yeah. So an example of that. So a valid statistical question like, how many hours did you work last week? Because if I go student by student and I ask, how many hours did you work last week? Each student's going to give me a different result, different answer, because everybody works a different number of hours. But if I ask you, well, who won the college football national championship game this year? I can ask anybody that question. They're all going to be the same answer because it's kind of a set in stone fact, right? That's not an answer that varies. Michigan won the college football national championship, so everybody would get that answer. So that answer doesn't vary. It's kind of a fact-based question. So a statistical question, a valid statistical question, has to be something that will vary from person to person, like how tall are you, or how many friends do you have on Facebook? Things like that. Everybody would give a different result, a different answer to. What's your favorite color? Things like that. Population. In a statistical study, population is the entire group of individuals. So everybody, obviously. So that's not really a surprise to you guys. A sample is a subset of individuals in the population for which we collect data. So if students at Cypress Creek is the population, a subset would be like, people in my class, right? A small group of people from that population. A census collects data from every individual in the population. So the United States does a census every 10 years where they sort of get information from every individual in the country to kind of count how many people are live in each state. They base the voting districts off of that and all, et cetera, et cetera. So a census in general, though, is just asking every single person. So I could do a census at this school, but it would mean that I ask every single person at this school that question and not just a subset or a small sample group, but everybody. Observational study observes individuals and measures variables of interest, but does not attempt to influence the responses. So an observational study, you kind of watch, right? So like I could stand in the courtyard and just watch the number of people walking by that wear Crocs, and I can record data on that, right? I'm not intervening. I'm just watching and counting, right? An experiment deliberately imposes treatments or conditions on individuals to measure their responses. So an experiment is where you kind of pull in more strings, like you set up different treatments and you assign people to those treatments. So you have a lot more control. It's a lot more regulated. All right. Let's jump down to some of these examples. So first example here on the left. Determine if each of the following is a valid statistical question. Explain your answer. So valid or not valid? Let me zoom in a little bit here. On average, how many days did students at your school play video games last week? So I'll ask a student, how many days did you play video games last week? I'll ask another student, how many days did you play video games last week? And if I go student by student, chances are they're all going to give me a different number. Oh, I played 2 days last week, or I played 5 days last week, or I played 7 days last week. So because everybody's going to have a different answer, that is a valid statistical question. Number of days each student plays video games. Varies. Everyone's going to give me a different number. Everyone's going to say a different result. Now, of course, some people will probably say the same thing, but generally not everybody says the same thing. B, are senior citizens more likely to choose vanilla over chocolate ice cream than teenagers? So I ask a teenager, hey, what do you like, vanilla or chocolate? They give me an answer. I ask another teenager, hey, what do you like, vanilla or chocolate? They give me an answer. I'm not going to expect that they all say the same thing, right? Some teenagers are going to like vanilla, some are going to like chocolate. Same thing with senior citizens. But the difference in the proportions is what matters. Hey, maybe 70% of senior citizens like vanilla, but maybe only 40% of teenagers like vanilla. Like, you'll have to figure that out. But is this a valid statistical question? The answer is yes, because everyone's going to have a different answer, and they won't say the same thing, right? Based on data that varies. Not everybody's going to say the same flavor, right? Some people say chocolate, some people say vanilla, so that varies, that changes. And then C, how many people in the United States were convicted of violent crimes last year? This one is not valid because it has one single answer, right? Question can be answered with a single value. Now, if I go up to different people, they might not know the answer, right? But if they do know the answer, it's a single answer. It's just a fact that you can look up on the internet and it's going to say the same thing. It doesn't vary. It doesn't change. All right. Now, identifying the population and sample in each of the following settings. So let me give you an example before we go through those examples. Let's say I ask 20 of my students how long they spent doing the last skill check assignment, right? That's it. I ask 20 of my students how long they spent on the last skill check assignment. The population in that circumstance is all of my students, not all of Cypress Creek High School, not all students at Pasco, just all of my students. And then the sample would just be the 20 people that I asked of all of my students. So in this case, a wildlife biologist in Alaska tranquilizes 42 grizzly bears in the state, records their weights, and then releases them. So the population here is going to be all grizzly bears in Alaska, not in general, but in Alaska, because it's grizzly bears in the state of Alaska. Now the sample, this one's a little more obvious, I would say, is just the 42 grizzly bears that were chosen. Right? But the population is all grizzly bears in Alaska. The sample was just the 42 grizzly bears in Alaska that were chosen. So hopefully that makes sense. Um, Population and sample. Look at example B. A fan selects 15 Beyonce songs and counts the number of words in each song. So the population is going to be all Beyonce songs, not all songs in general, right? Because we're only talking about Beyonce, but all of Beyonce songs is the population. The sample is just the 15 songs that they chose to count the words in. So again, hopefully that makes sense. So the population is all the Beyonce songs. The sample is the 15 songs that were chosen. And then final couple examples over here is determine whether the following describe an observational study or an experiment. So the first one says that 60 4-year-old children were randomly divided into 3 groups. One group was shown a fast-paced cartoon, one group was shown an educational cartoon, and one group was given art supplies and instructed to draw pictures. Afterwards, the 4-year-olds who watched the fast-paced cartoon scored significantly worse than the other 2 groups on tests that measured the ability to make decisions. So this right here is an experiment. The reason it's an experiment is because you have different treatment groups that were designed and uh, different children were assigned to those groups. So treatments imposed. Right? You had 3 treatments, the fast-paced cartoons, the slow-paced cartoons, and or I guess the educational cartoons, sorry. And then the art group. There you go. Right? So different treatments were imposed. You got 3 different treatments there. Now, if you look at B, 100 teenagers between the ages of 16 and 18 were surveyed. The teens were asked whether, as young children, they watch fast-paced cartoons more often, less often, or about equally as often as educational cartoons. They were also asked to reveal their GPA. The teens who watched fast-paced cartoons more often than educational cartoons had lower GPAs than teens from the other 2 groups on average. So this one is an observational study. You're going to notice in this one, um, there's no treatments imposed here, right? We're simply asking about things that have happened already in the past. We're not controlling anything. We're not assigning anybody to any groups. We're just asking questions about things that they had done previously. So it's really kind of more of a survey, but that kind of falls under the classification of observational study. So yeah, there was no treatment imposed. Um, what else? The teams were not told which cartoons to watch. or for how often? Right, so we're not controlling anything. We're just asking how much they've already watched, basically. Um, that's about it. So that's gonna do it for 5.1. I'll post this. You publish this on the website for you guys. So copy down if you need anything. If you have any questions, let me know in class. But I'll leave it there. So yeah, have a good rest of your day, and I'll see you in 5.2. Bye for now.